We just have to note the total lengths. Well, my total length here to here is 10. My total length from here to here is 8. Does that mean this center area is 8 times 10?
No.
No, it means that total area is 8 by 10. That is not that. Well, the distance from here to here is definitely not 8. It is 8 minus 3 minus 3, because each of those squares, it says in it we're cutting out 3-inch squares. Each of those squares is 3 by 3 by 3 by 3. So all of these sides, even though they don't look like squares, are 3s. So that means from here to here is 8 minus 3 minus 3. So it's 8 minus 6, which is 2. Same thing for our total width. Our total width started as 10, but I cut off 3, so it's 10 minus 3, minus 3 again, which is 10 minus 6, which is going to give me 4. So that total area of our base, once we flip this up, is going to be 8. So that area of that base, area base, is going to be 2 times 4, which equals 8 inches squared. Well, that's just the area of the base. I didn't get the volume yet. Recall that volume is my base times my height. Well, my base is 8. And what's the height of this box once I flip these guys up? What was that? It's going to be 3. Because I'm cutting off 3 inches, so my fold is going to be 3 inches. So my height is 3 inches. So my volume is going to be 24 inches cubed. I like problems like that. We're going to have it on a sorted. It says it's a challenge problem, but after seeing it, is it that much of a challenge?
No.
It's just about doing things correct. Remember that path one? Remember that one where we had a path that went across that garden pool that one day? The only people that got those wrong were the ones that didn't subtract, the side twice. All right, that was the biggest mistake on that test, was you just subtracted 3 out. Just account for both sides. That this is 8 minus 3 minus 3. That's why I always tell you to do a good drawing. A good drawing will lead you down the right path. Yeah?
The 3 came from you flipping the sides up.
Mm-hmm.
We know that box up there is 3, right?
Mm-hmm.
So it's the same height as the sides.
Yeah. Because it creates that 3-dimensional box, right? Because it's just like what you probably did as a kid. You just take a sheet of paper and fold it up 3 inches, up 3 inches, up 3 inches. Maybe I'll bring an example in next time we do it. Okay, what questions do we have on the homework? Yeah, Maurice. So number 4 was kind of like a challenge question. It was, and I gave you that hint. So on number 4, I gave you the hint that it's area, our base area times our height. Well, my base was 11.4, but this length wasn't my height. This length here was my height. And that was 5.1. So you should have did the 11.4 times the 5.1, which would give you the 58.14 feet squared. So no matter if it's slanted or not, we still multiply it by the height, not the slant. Okay, other questions? David?
21.
21? Is that still around?
No, it's not.
I was going to say that was... Okay. Okay, we have a right cylinder with a base diameter of 24 and a height of 15, has a sector shaped slice missing. If the arc measure of the missing sector is 45 degrees, what is the volume? So remember, volume is just our base times our height, right? So they're saying that we have a circle. I'm just going to draw the base, okay? We have a base circle that's missing a wedge out of it that happens to be 45 degrees. Does that make sense, David? All right, so once I calculate that, I just have to multiply it by the height because we already know the height is 15. So the diameter of it is 24, so that means it has a radius equal to 12. And to get the area of that base, well, if this is 45 degrees, what is this total area if that's 45 degrees?
250. I mean, well, yeah, 250.
Yeah, you're right. Well, not 215, but
It's not.
because it's 360 minus 45. I think you did 260. Yeah, 315. So it's going to be 315 degrees around. So that means the area of this section here, this area, is going to equal 315 divided by 360 times pi r, which is 12, squared, and we just take that and multiply it by the 24. Does that make sense?
Yeah.
So the best thing to do with volume is just figure out what your area of base is. All right, because even if you have this drawing and you mess something up here, at least I know you're doing the right stuff, and I give you a lot more points on it. That's how a lot of you got points on this test. You drew really good pictures, and a lot of you just described what you were going to do, and you were really close to getting the actual answers a lot of times, just describing it. All right, so at least I know you know what you're doing. So draw. All right, other questions? Yeah. 11. 11. 11 was actually, well, I have the right answer, but I have the wrong work. So a lot of these I just did in my calculator, and I just transposed them into the thing. So this is the wrong work, but it's the right answer. So to do number 11, we just have to come up with this area, right, the shaded area. So the first thing I did was I calculated, let's pretend like those circles are filled in. I'm going to calculate that whole area. Well, that's half a circle. That's half a circle, and the area of a circle is pi r squared. So I took half of pi r squared. That's the entire shaded region. The next thing I want to do is I want to subtract out the area of those little circles. Well, if we notice, we have two of those. We have two of those little circles. So I'm going to have 2 times, and they're half circles, so it'd be half pi r. My r is going to be 3 for those little guys. Squared. Because if this is 6, this must be 3. So this is going to be the area of both of those circles. So that's what I'm missing here. I'm missing that half here. So rather than this being here, this guy should be here. And then it comes out to 90 pi. Once we multiply by the height. Does that make sense? Oh. Other questions? Yeah, Brian. 8. All right, 8 is just 2 shapes. So 8 is calculated in the shape of this box, which would be 4 times 6 times 4. And then we're going to add this shape on it, which is half a box. So it would be 4 times 6. So this area here would be 4 times 6 times 4. And this guy up here, well, we could do a couple different things. So we could count the triangle. So we could say the triangle would be half a base times a height. And our base was 6. Times our height of 2. And then we'd multiply that by 4. and we add these two things together, we get the total area. Okay, so it's just breaking it apart and adding it together. All right, other questions? Yeah. 25. All right, 25 is a right cylinder, has a height of 18 centimeters and a volume of 450. Okay, so we have a right cylinder that has a height of 18 centimeters and a volume of 450. So that means that our volume, remember that our volume is going to equal a right cylinder has a height of 18 centimeters. So our volume equals our base area times our height. Well, that's 450 pi equals, the base area is a circle, so that would be pi r squared, times our height, which is 18. Well, when we solve this equation for r, we end up with our radius equals 5. And just remember, the surface area of a cylinder is going to be a circle, a rectangle, another circle where this is pi r squared, this is 2 pi r, and this is whatever your height is. Alright, so your key was to write down this volume and actually realize that your base area of a cylinder is pi r squared. That gets you your radius. Okay? Other questions? Okay.
Somebody asked about 24.
There's one right next to it. No, we can talk about it. So a rectangular cake pan has a base of 10 centimeters by 12 centimeters and a height of 8 centimeters. If 110 cubic centimeters of cake batter is poured into the pan, how far up the side will the batter reach? So you would have came up with your total area, right, or your total volume? And what does your total volume come up to? I don't have that.
It's probably around
Um,
960.
Well, you just do 10 times 12 times 8. So that's 960.
Yeah, that's what I had.
So we're going to do 810 divided by 960. That's what percent of the volume's taken up.
Okay.
And then we just got to realize the height, right? The height of that pan is going to be 8 centimeters. So you're just going to take that percentage and multiply it by 8 centimeters, and it's going to say how high it went up. And that comes out to 6.75. Does that make sense?
Mm-hmm.
So percent of your volume is going to be the percent of how high it goes up. All right, that's got to be our last one, because that's been about 10 minutes. If you have other questions, please come see me or check. The answer key has just answers on it, basically, but please see me so we can go through them in more depth. All right, today we're going to talk about volumes of cones and pyramids. So we're going to start with a volume of cylinder, because obviously the volume of cylinder must have something to do with a cone, because they're very similar shapes. So the volume of a cylinder is going to be our base area, which I'm going to put as a boldface B, that's my base area, times my height. Well, my base area of a cylinder is the area of a circle. A circle is pi r squared. So that means the base of this one is pi r squared, and our radius is 5, so it's pi times 5 squared times our height, which is 12 centimeters. And that's going to give me a volume is going to equal 300 pi centimeters cubed. We should know how to do that. And in fact, if you know how to do that, you know how to do a cone. All right? So we know how to do this cone. The first thing I need to figure out is our base is the same. Both our bases have a radius of 5 centimeters, so they're the same between the two. I don't know if the height is the same, though. So I do have to check to make sure the height is the same. Well, there's a right triangle here with a hypotenuse of 13 and a side of 5. So we're going to use the Pythagorean theorem to come up with 13 squared. Minus 5 squared is going to equal that c squared. And I'm going to shortcut that and tell you it equals 12. So if you did 13 squared minus 5 squared and you took the square root of that, you'd come up with 12. In fact, because 13 squared is 169 minus 25 equals 144, the square root of 144 is 12. And I'm sure everyone did that in their head too, right? Yeah, no problem, right? Okay, so I have a cylinder that has the same base as my cone and the same height as the cone. Just by looking at those two pictures, if I put this cone inside of here, how much of the area would it take up, or how much of the volume do you think it would take up, based upon that picture? We have one person that has a guess. I'll do a guess. I bet you it's 2% of the total space. You're wrong. So embarrassed. Make a guess. Madison, what do you think?
33.3%.
33.3%. What do you think? 1/2. Any other guesses? David, you moved. Half? Anyone have other guess besides 33.3 and a half? Half? Half. I would say most people would kind of look at that and say that that's about half. Because just on face value, it kind of looks like it's half. Unfortunately, I wish I had them, but I used to have a set of these that didn't make it here. They're ordered on Amazon, but they're taking forever to get here. Basically, what we're going to do, or what this is showing, is if I fill this cone up with water, they're the same base, they're the same height. If I fill it with water, if it fills it up halfway, it means that it's half the volume. If it fills up 3/4 of the way, it means it's 3/4 of the volume. If it fills it up 1/4 of the way, it's 1/4 of the volume. So let's just see what happens when he fills it up with water.
Let's go ahead and fill him up with water and see if this actually works out. So here's number 1. Here's 1.
It's a 30.
Oh no, it jumped way over.
Is that fun again?
Where are we? There we go. It's funny, his voice.
You guys don't make fun.
Is that... Where's that looking?
33.3%.
It's not half though, is it?
No.
Half would actually be about here. So it's not half, so let's just keep looking.
And finally, the last combing should fill up to the very top. And here we go. Number 3, 1, and 3. And as you can tell, it is absolute.
It is absolutely perfect. It is exactly 1/3.
That's crazy.
I would have gone with half too. It just looks like half, right? It just looks like half. Jack, I'm glad you're entertained. Were you the one that said it's crazy?
Yeah.
All right, so the volume of a cone is exactly 1/3 the volume of a cylinder. So if you know how to calculate a cylinder, you know how to calculate a cone. Because like I said, the volume of the cone is 1/3 that of our cylinder. So that means our equation for this one is going to be 1/3 times our base area times our height. Our base area was pi 5 squared times 12, which we already did the math over here, comes out to 300 pi centimeters. So our actual volume is going to equal, I should put a V there. Our volume is going to equal 100 pi centimeters cubed. And that's it. That's why it took so much time to practice the volume of a cylinder, because if you know that, you know the volume of a cone. In fact, we can apply it to any pyramid type shape. If I have a rectangular based pyramid, it is going to be exactly 1/3 the volume of a rectangular prism. And remember, a rectangular prism is just our base times our height. So the volume of this rectangular prism is 8 times 9 times 12. And that total is going to come out to 864 centimeters cubed. So a rectangular base pyramid which has the exact same base and the exact same height is going to equal 1/3 that total. So 1/3 times 9 times 8 times 12, which comes out to 288 centimeters cubed. Once again, if you know how to calculate this, you know how to calculate this. So volume is just of a pyramid or a cone is 1/3 our base. So once again, the base is really important to figure out what shape it is and what the area is. Now we just multiply by the height. So 1/3 our base area times our height. Okay, the next problem introduces a little more difficulty into the process. It says the volume of a trapezoid-based pyramid is 572 centimeters cubed. What is the value of B? So B is right here. B is part of my base. So I'm going to write down the area of, so volume is going to equal area of my base times my height. Well, I already know the height is 22, so I just need to figure out what the area of this base is. So I'm going to go ahead and redraw that down here. I'm going to redraw that base, because that's one of the most important parts of our volume. Well, we have B up there, we have 8 here, and we have a height of 6. Jack, what is the area of a trapezoid?
Base times.
So what is the actual area of a
It's
trapezoid?
average of the bases times the height.
There you go. It's the average of the bases times the height. Which is going to look like half. I'm just going to put our height first. So it's half of our height times base 1 plus base 2, which is going to equal 1/2 times 6, so that's 1/3 B plus 8. So that is our area of our base. So let's plug in the information I know. I know the volume is 572. I know the area of the base. Well, that's 1/3.
Wait, how is it 1/3?
Yeah, wouldn't it be 3?
Oh, I'm sorry, 3. Yeah. It would definitely be 3. So we'd have 3 times that B plus 8. And we're going to multiply that by our height of 22. What am I missing from that formula? No one's corrected it yet. But something very big is missing. Who else has it? I gave you the answer. I was thinking about missing it. That's why I came up with the mistake that you saw. What am I missing from this formula? It's something that I put in and then had to take out because I put it in the wrong place. Isabel. I'm missing a 1/3. No one corrected me on that. Thankfully, Jack corrected So I was so busy trying to make sure I didn't write 1/3 that 1/3 was in my head. This should have been 1/3. Our area
So it's 1.
base. Yeah, it's going to become 1. But let's see why it's going to become 1. So I shift that over. And I should have 1/3 times all of this. But Jack just said that becomes 1, right? Okay, so one more time. If you're not sure what to do, because on Monday we're going to kind of do more of these challenge problems. These aren't really challenge. But if you don't know what to do, write down your formula and see what you can plug in and solve. All right, let's go ahead and get started on our homework. I'm going to write in the fact that this is 8 and this guy's 5.